Hello and good morning, CSI257 Section 847 students for the first 8-week term of the spring 2015 semester at Anne Arundel Community College, where we're going to be taking a look today at PacketTracer Activity 9.3.1.4, which is the last PacketTracer activity of this course, and this is the Cisco Networking Academy Scaling Networks course, Chapter 9, and it's the Anne Arundel Community College Networking 3 course. All right, so let's go ahead and jump in here. It's sort of a transition here after covering 2 chapters of EIGRP, where we had Chapter 7 and Chapter 6 basically focused on EIGRP. We're now kind of shifting gears here and taking a look at the final activity, which is going to be a multi-area OSPF activity. And here is our scenario. So we're basically a network technician. We're going to have to apply all of the skills that we've gathered about OSPF so far and implement those skills. So the R3 LANs need addressing. Complete the variable length subnet mask design using the next available subnets in the remaining 172.31.30/23 address space. So if we take a look here, we'll go ahead and start with our subnetting. And we'll see that the R3 LANs, well, we have 2 LANs here, and they both need 120 hosts. So we should be pretty familiar at this point in being able to say that if we have a /24, then that equals 8 host bits. That's going to equal 2 to the 8 minus 2. And the reason we subtract that 2 is one is for the network ID, and the other is for the broadcast address. We'd have 254 addresses. And then we have a /25, which leaves us with 7 host bits. And that's going to be 2 to the 7 minus 2, which is going to be 126. So this one's looking pretty good right now. And we know that if we drop down to a /26, we're going to have 6 host bits. And that's going to give us a grand total of 2 to the 6 minus 2. So we're going to have 120, I'm sorry, 120, I was looking above there. We're going to have 62 available host addresses. So if we need 120, this will be the subnet size we would want to go with. And a /25, as we've seen before, the net mask is 255.255.255.128. So that's basically going to split a /24 into 2 /25s. And so let's take a look and see where things ended up here. So we're supposed to be using the remainder. It says the next available subnets in the remaining 172.31.30. And so if you take a look here, we used the 172.31.29 and the 172.31.28, but we've never used the 31.30. We've used 31.31. So what we're going to have to do, and this is kind of where when you take a look here, you really need to be aware of the fact that it looks like they're using 172.31.31, but a little further down, and then there's a 250 and a 254. So we're going to go ahead and start right at 172.31.30.0/25, and so that's going to mean our first available IP is .1. Our last available IP is going to be .126. Our broadcast will be 127. So this will be subnet number 1. And then our second subnet is going to be 172.31.30.128/25. Our first usable, which is always odd, is going to be 129. Our last usable, which is always going to be even, is going to be 254 with a broadcast of 255. And this is going to be subnet number 2 that we're going to go ahead and use. So the gig 00 interface will be subnet 1, and then the gig 01 interface will be subnet 2. So let's go ahead and jump in here. It says assign, where are we at? Assign the first subnet for 120 hosts to the R3 LAN 1 assign the second subnet to R3 LAN 2. And so let's go ahead and jump on our router R3, where it looks like we're going to be doing quite a bit of work here, at least initially. And we're going to go from user exec mode into privilege exec, and then into global config. And it looks like the first available address is going to be document the addressing scheme. So we've done that. We kind of completed our table to the right there. So assign, they're looking for us to assign the last IP address in the subnet to the appropriate R3 interface. So let's go ahead and do a show IP interface brief. So we've got 2 serial interfaces, 2 gig interfaces. So let's start with gig 00 first, and let's see. I'm going to go ahead and do a no shut so we can identify it. And there it is. That goes to our R3 LAN 1. So assign the last available IP address, 172.31.30. And this is our first subnet, so the last assignable host IP is .126. And now let's get our subnet mask in there of 255.255.255.128. So I'm going to go ahead and hit enter, and as you can see, we got some points there, so we're definitely on the right track. All right, now let's transition over to Gigabit Ethernet 01, and this is going to be toward that R3 LAN 2. I'm going to say no shut. And the interface comes up there, so that's a good sign. So we'll say IP address 172.31.30. Last available here, and let's confirm that. It says assign to the R3 interface, so we're going to stick with 254. That is our last usable host IP. And our subnet is going to be 255.255.255.128. So now the second bullet there, it says assign the first IP in the subnet to the PC. So let's knock that out right now. Pull up our desktop. We're going to say static. So for the R3 LAN 1, it's going to be 172.31.30. Dot, and the first usable is going to be .1. Our subnet mask is 255.255.128. Did I type in 192 earlier? I hope not. And our default gateway, and this is going to be that address that we just assigned to the gig 00 interface, 172.31.30.126. No DNS server is listed, so let's check our connectivity here. Can I ping my default gateway? 172.31.30.126. All right, fantastic. So I can ping my default gateway from PCE. Let's jump on PCF. And we're going to do a static here, and this is going to be 31.30. Then the first assignable in that range is 129. And we're going to change our subnet mask to 255.255.255.128. And again, we need to make sure we get our default gateway in there so we can get off of this segment and hopefully out to the internet. So 172.31.30. And remember, the default gateway is going to be the router interface for the R3 LAN 2 segment, and that would have been 254. And let's confirm this. So I'll close my config down, and let's see, can I ping my default gateway? 172.31.30.254. All right, good news, we've got connectivity. Can I ping PCE over on R3 LAN 1? Let's make sure we can get over there and back. So I would say ping 172.31.30. And the first assignable would have been .1. And so I can actually ping PCE, and so that's great news. We've got connectivity all the way through. All right, configure addressing for R3, PCE, and PCF. So we just did this, so we should be good to go, but we're going to want to make sure, do show IP interface brief. I want to make sure that the serial interface, okay, so the serial interface is configured, so we're good there. So now we're going to implement multi-area OSPF using 1 as the OSPF process ID. So assign the serial links to OSPF area 0. So I'm going to go ahead and start right here, and we're going to say on router 1, we're going to say router OSPF 1. and it's asking for the router ID, so we're going to make that happen. So we would be 3.3.3.3 because X is the number router, and that's what we're going to go ahead and use here. And then it says assign the serial links to OSPF area 0. Well, to assign the interface, I would use the network command, and we're going to say 172.31.31. Excuse me. So this is a /30, as we can see in the addressing table, right? 255, 255, 255, 252. And that's our IP. So we know that the other IP is going to have to be 253, which means that the network should be 252. We're going to throw a wildcard mask in here for a /30, and I'm going to say area 0. So we've added our statement in there, and we've placed the R3 serial interface into area 0. Okay, so let's go ahead now and let's make sure I've got this right. Let me see here. Lands to OSPF. So on R3, we're going to put these 2 gig interfaces into area 30. So let's do that right now. We just did our subnetting over there, so this should be pretty straightforward. 172.31.30.0, and the subnet mask for, I'm sorry, the wildcard mask for a subnet mask of 255, 255, 255, 128 is 0.0.0.127. Remembering that the wildcard mask is the inverse of the subnet mask, and we simply take the subnet mask and subtract that from the all 255s. So we're going to put the first interface into area 30, and then I'm going to recall this command, and we're going to come back here and say network 128, and it is also a /25, so the wildcard mask will also be 0.0.0.127, and that should take us up to around 40 points if we're getting points for both or just one. Okay, so we've got both of those interfaces entered in there, and so they're both now in area 30. So if I said do show IP protocols, we can see we've got OSPF process ID 1 up and running. We've got our router ID configured, and these are the 3 networks for which we are routing. So the single area 0 network, and then the 2 networks that are in area 30. All right, so that for right now. Oh, and it wants the routing updates not to be sent, and we cannot use the default argument. So here's what we're going to do. I'm going to go ahead and say, we're going to just simply say, not default information originate, sorry about that, passive interface, gig 00, because we can't use the default. So we have to pick off the interfaces one at a time, and gig 01. So let's take a look right now. That should get us, and we're going to have to go into router 1 and 2. So if I were to say do show run, and we wanted to look at our OSPF setup, there we go. We have it right there. So router OSPF 1, our router ID is set. We have our 2 passive interfaces, and then we have our OSPF network statements, which start the OSPF process on those interfaces so that they can try to find neighbors, which is why we passive interface gig 00 as well as gig 01. Neither of those interfaces has OSPF speakers on the other end, so we don't need to send those hello packets. Okay, so I'm actually going to do the same steps here. Let's take a quick, let's do a level set here on router 1 and router 2 to see where these guys stand with respect to their configuration. So we're going to go from user exec into privilege exec. I'm going to say do show IP actually, so used to be in global config. So show IP interface brief, and it looks like both of the gig interfaces are already set up. The serial interfaces are already set up. So let me do a show run here, and let's see well actually, how could I check to see if OSPF is running without doing a show run to see if that configuration is there? Show IP protocols. So we've got nothing running, so we definitely are going to be configuring router 1's OSPF setup. So let's go ahead and jump in and knock that out right now. And we can also use the addressing table to the right there to take a look at what router 1 is going to have in terms of interfaces. So I'm going to say configure terminal to go into global config mode, and I'm going to say router OSPF 1. Because again, we're right back here at this section. We're going to be doing this for router 1 and 2 to make sure that they're the same as router 3. So we've got the router OSPF 1 set up. The router ID is simply going to be the all ones. And the serial links are going to be in area 0. Let me make sure. Summarize the LANs in each area and advertise them using one network statement. Aha! So I skipped right by that. So it wants us to summarize the LANs. So I am actually going to go ahead and say no, and I'm going to pull these guys out, which could be why I totally missed that, and I apologize. So let's pull these network statements out here. So it wants us to summarize, and this is going to be a very easy summary because we know we're simply dealing with a single /24. So what I would say, and if you do the question mark, you can see that we're going to, let me make sure, summarize the LANs in each area and advertise them using one network statement. So we're going to use 172.31.30.0, and we're simply going to say 0.0.0.255 area 30. And so that is going to be, that's going to meet that requirement there. And I read right by that the first time. All right, so back over to router 1, where we're going to be doing much of the same thing. So assign the serial links to OSPF area 0. So I'm going to say network, and the first serial link is a 172.31.31. And it's a 252. And the IP is 249, so this is in that same 248 network, along with our serial 000 interface. So the wildcard mask for a /30 is a 0.0.0.3, and this is going to be an area 0. And what we should also see happen here is we should also see, actually that's router 2's connection. Now we'll go ahead and do our network statement with router 3. We should see the adjacency come up. 172.31.31. Let me go back up here and look. 172.31.31. 253. So that's our connection to the 254, which means the network is going to be 252. And then we have a /30, so it's going to be 0.0.0.3, and this is area 0. And now we should see our adjacency come up here shortly, and there we go, fantastic, with router 3. All right, but let's make sure we continue on here. We did the router ID. Now we need to summarize the LANs in each area. So area 10, as you can see, those are /23s, right? So those are substantially larger than the /25s we were dealing with earlier. And so 2 /23s is simply a single /22. And so let's go ahead and work that out. If we look here, you can see that it's going from 172.31.25 up to 172.31.27. So let's work this out. So I'm going to go ahead and clear that off because we've already used that information. So if I have 172.31.27.0/20, make sure I get that right, 23, we've got 510 possible host addresses there, right? And then we've got 172.31.29, was it 29? No, I apologize, 31. So we'll pull that off. 31, and I did skip that, didn't I? Hold on one second. So it's from 25 to 27. So this is, we'll say this is 25. I was going to say, I looked at that and I was like, I don't think we've got the right. Let me pull this back here. So this is going to be 27, and this is going to be 25, right? 27.0/23. And again, this guy's got 510 possible assignable host IPs. Now remember that a /23 is just 2 /24. So really, the range here is from 172.31.25.0. It also includes 172.31. Let me pull this back. 31.26.0/24 sits in there. right? And then it picks up at the 27. So if we were to summarize this just based off of the /23s, where's the interesting octet? Well, it's right here, the 25 and the 27. So now we need to say 25, what is, whoops, I apologize. Sorry about that, brief interruption there. So where we left off was we're going to summarize these two routes, these 2/23. So 25, right? So we know it's not going to be 128, it's not going to be 64, it's not going to be 32, but it is going to have 16 in there. And then it is going to have 8 to get to 24, and then 0, 1, 2, 3, 4, 5, 6, 0, 1. And so that is equal to 25. And then we're going to do 27. So 1, 2, 3, it's going to have 16, and it's also going to have 8 to make 24. Now, it won't have the 4 because that would make it 28, but it will have the 1 and the 1, right, for the 2 and the 1. So 16 plus 8 is 24, 25, 26, 27. So what are we looking at here? So these guys are the same all the way right up until that bit position, the next to last bit. So we've got 1, 2, 3, 4, 5, 6 additional bits that match. So we've got 8 here from the first octet, we have 8 from the second octet, and now we have an additional 6 that match. So that gives us a total of 22. Because remember, a /22 is just simply 2 /23s, and a /23 is just 2 /24s, right? And a /24 is simply 2 /25. So we know we're going to have a subnet mask of /22. Now we need to figure our value out. So we're going to be 172.31. And now we have bit positions that have values on, and it's the 16th and the 8th, right? Or I'm sorry, the 16 position and the 8th position for 24. So it's 172.31.24.0/22. So our subnet mask with a /22, remember, we're going to only be using 6 of the 8 bits in the third octet, so it would be 1, 2, 3, 4, 5, 6, 7, 8. So we've got 128, 192, 224, 240, 248, 252. So this is going to be a 255.255.252.0. And so we're going to roll with this for our summary here on router R1. And let me make sure and advertise I'm using one network statement. So we're going to say network 172.31. And I'm sorry, I put 30 over here, didn't I? Did I put 30 over here? Okay, I did not. All right, good. 172.31.24.0, and this is going to be, let me make sure I've got this correct, 25 and the 27, and that is 24. Okay, so we are good. So we're going to go ahead and say it's going to have a wildcard mask of 0.0.3.255, and that is going to give us, and this is in area 10, that is going to give us our summarized network statements for the R2 LAN 1 and LAN 2 segments. All right, so we got the router ID, we got the serial interfaces, and we've got these guys in area 10. So we're good there. Prevent routing updates, right? So, and we can't use the default command. So we're going to say passive interface gig 00 and passive interface gig 01. Now let me double check. Yep, gig 00 and 01. So we are good there. All right, so now we're right down to this step here. Implement default routing, and in fact, correction there, we need to get on to router R2. Don't let me forget router R2 here. Okay, so let's pull router R2 up, and go to the CLI. We're going to do the same things that we just did for router R1. So I'm going to go from user exec to privilege exec into global config, and we're going to go ahead and say router OSPF 1. We're going to set the router ID to all 2s, and now we're going to need some network statements. So we want to summarize the LANs. So if we look at router 2, so router 1 had 2/23s, which is a single /22. So if I were to tell you that router 2 is sitting on 2/24s, that would be a single /23. And so we know it's going to be a /23, but let's go ahead and work it out here. Router 2 is 28 and 29. So 172.31.28.0/24 and .29.0/24. So what do we have? We've got 28 and 29. So 28 in binary is going to be 1, 2, 3, and then 16. The 8 position is definitely going to be on for 24, 28, and then 0, 0. And so then 29 is pretty easy to do. 1, 2, 3, and we just need one more. So where do these guys no longer match? They no longer match on the 23rd bit, because you got 7 bits here. We already had 8 bits with the 172 and the 8 bits with the 31 for 16. Plus 7 is going to be a /23. So we should be pretty adept at this by now. It's going to be 172.31.28, and it's 28 because these bit positions are on in the summary. And .0/23. All right, so let's add that in here and we'll get that set up. So we're going to say network 172.31.28.0, and it's a /23, so it's going to be 0.0.1.255. And these interfaces are in area 20, right? So we see our completion percentage jump up a little bit there, so that's a good sign. So we've just summarized that, and let's get our serial link as well. Let's not forget that serial link. I almost ran right by the serial link there. So it's serial 000, so 172.31.31 dot, and if it's 250, and it's a 250, it goes up to router 1, who is 249. So that means that this is going to be 248 as our network ID, and a /30 is always the easiest for us, and that is in area 0. So that now adds the serial interface into area 0. So we've got our serial link set up, we've got our router ID set up, there's our adjacency with OSPF that is just established, and we've already summarized the LANs into a single network advertisement in area 20. So if I do a do show IP route, we should see some intra-area routes. So here's an intra-area route, which is our transit network between ourselves and router 1, but we see some inter-area routes, our type 3 LSAs, right? And we know this because of the OIA. So if I were to say do show IP OSPF database, let's come down and look at our summary netlink advertisements. Here they are. And who is the router that's advertising these to us? It's 2222, right? So that is us. It's router 2. And we're getting these from area 0, and they're coming to us as type 3 summary LSAs. And again, it's not summary in the sense of we're summarizing routes like we've just finished up here. It's not the same thing. So when we're saying summary, it's giving us a summary of the link state database that's in that foreign area, right? And so we only get limited information about the other areas that are not the area that we are sitting in. So not area 20, right? So area 30 and area 10. And if you look at the transit networks here, these are from area 0. Okay, so you've got our type 1 LSAs. We also have, there are no network LSAs. So we do not have any DRs or BDRs being elected, and that should make sense, right? So take a look here. Do we have any multi-access segments? We do not. So all of our adjacencies are being formed on point-to-point serial links, and by default, there is no DR BDR election on a point-to-point serial link. All right, so let's go ahead now, prevent routing updates. So we need to make sure we get the passive interface gig 00 and the passive interface gig 01 done. And we did not use the default. So now we're going to implement default routing to the internet. And that's going to happen here because R1, he has the connection out to the internet. So the first thing that we need to do is we need to go ahead and set up our default route. And is it asking? Yes, for a directly attached default route. So do show IP interface brief, and it is serial 010. So I'm going to say IP route 0000. Whoops. Get my quad zeros in here, and it's simply directly attached. So serial 010. And then we get that familiar error, right? Just reminding us, be careful, and if it's not a point-to-point interface, you may incur a performance penalty. All right, so we've got that set up, and now we just go into the router OSPF 1, and we're going to say default information originate. And before we do that, if I look at router 2 and say do show IP route, you can see the gateway of last resort is not set. Let's check router 3. So we'll say show IP route. Gateway of last resort is not set, but that is about to change when we hit enter right there. So now if I step over to router 3 and say do show IP route, I'm sorry, show IP route, now we have our default gateway set up, and there is, as we would expect, the type E2, the OSPF type E2 candidate default route. And we're going to see that same thing over here on router 2 now, where a minute ago we saw nothing. So there it is. Whoops. So there it is right there. And again, there's our candidate default route. We advertised it. So now we've got MD5 authentication. So we're going to start on router 2 since we're here. So where do we want the authentication to take place? Well, we want that in area 0, right? And what kind of authentication? Message digest. We want the MD5 because that, for our purposes, is the most secure way to do it. And I stress for our purposes because there are more secure ways to do this. They're just not covered, a little outside our scope, right? Okay, so we've got the authentication message digest set up. Now let's jump into that serial interface, and let me double check to show IP interface brief. Should be 000, and it is serial 000. And what are we going to say here? We're going to go ahead and say IP OSPF message digest key, and it's telling us use 1 as the key, MD5 as the authentication hash, and then the password is going to be Cisco 123 as the key string. All right, so we did it there. Let's go up to router 1 and knock it out up here on router 1. So we're going to say area 0, which is where we want the authentication. And what kind of authentication do we want? We want message digest. So now I'm going to go into interface serial 000, and we're going to say IP OSPF message digest key is going to be 1 MD5 is the hash type we're going to use, and the password is Cisco 123. Now that should reestablish our adjacency with router 2, and as you saw, the adjacency did go down. Okay, so there we go. So we're back up. That's all good news. Let's do the do show IP interface brief. I believe it is serial 001. It is, so interface serial 001, where we're going to run that same command that we just did, which is just IP OSPF message digest key 1 MD5 and our password. Now this is going to break the adjacency when the next hello packet gets sent out. And if I do a do show IP OSPF neighbors, now this will be interesting to watch. We should see that message any second now because we're past the hello time. Oh, and it looked like it's counting up. It should be counting down. Did I not do the right interface on R3 from R1? 254 serial 001 do show run, and it might be, let's see, serial 001. So we have it in there, and it's not on router 3. So this might be, it's interesting because it tore down the relationship with 2 and 1. And so, yeah, okay, well, we've received a message here telling us that it's down, but we didn't see anything on router 1, or if we did, it's possible that I missed it. So let's go ahead and go into global config mode, And we're going to set up authentication right here. And we're going to go ahead and say, router OSPF 1, and what do we want to do? So in area 0, we want to set up authentication that is of the type of message digest. So then I simply need to go into serial 000. Let me check this out, make sure here. Serial 001, that would have been a disaster. All right, so then it's IP OSPF. Message digest key is 1. We're going to use MD5 as our hash, and the password is Cisco 123. And so we should see the adjacency reestablish here on between 3 and 1. If I do a do show IP OSPF neighbors, and there it is, we are now good to go between router 1 and 3. So do show IP route OSPF. So there are my OSPF routes, right? I've got the transit network, which is my single intra-area route right here. And now I'm picking up, I've got 4 inter-area routes that I'm learning on the serial 001 interface from router 1. And then, of course, we have our default information originated default route statement here that we're also learning from router 1, and it is of type E2. All right, so that takes care of the OSPF authentication. The final thing on router 1 is we are going to set up an ACL. And I am going to say, and this is going to be on the VTY line, so let's see if we should have 0 to 15, and we do. So 0 to 15 on the VTY lines. So configure an ACL, so we're going to say Accesslist, because again, remember, I'm going to give it a number. If I were to say IP Accesslist, I could still do standard, but now I can put the number in or the name. So we're just going to stick with the Accesslist and then the number. So the ACL is number 1. Whoops, sorry about that. Accesslist 1 permit. So who are we going to permit? Well, it's going to be PCA, and PCA's IP is 172.31.24.1 is what it looks like. PCA, let me make sure I'm getting that right. All right, so there's the access list. So now what we need to do is we need to apply that access list to those VTY lines. So line VTY 0 to 15, and I'm going to say access, access class 1 inbound, right? So I'm setting up the ACL to be placed onto the VTY lines, and we'll hit enter. And as you can see, that kind of maxed us out over here at 100 out of 100. So let's test connectivity though. We'll test from PCF here, and PCF should be able to ping out to 64.100.1.10. And there's definitely going to be maybe a drop ping or 2 while the ARPs are on their way, and there it goes. And now we've got full connectivity that way. Let's test PCD going the other way. So we're going to say ping 64.100.1.10, and look at that, PCD's got full connectivity out there. How about PCB? And from PCB, let's ping PCD. Is that a good choice? Or PCE. So we're going to say ping, ping 172.31, and actually we're going to pick a different, we'll do D, one where we have it right there in front of us, 29.1. I can't remember what we assigned to ENF. All right, so there we go. So we've got full connectivity. We've done another multi-area OSPF setup, and I love the skills integration challenges. They really force you to take all of the skills that you've learned in a certain subject and then apply those in a certain aspect of what we've been studying. All right, so this wraps up the final PacketTracer for the first 8-week term, PacketTracer Activity 9.3.1.4. I will see you all Saturday, and thank you so much for watching.